So let us discuss about velocity selector.
Selector.
Selector. Okay, so what is that velocity selector? Suppose you are having, this is 3-dimensional axis. Yes or no?
Yes, sir.
Okay. So now in this 3-dimensional axis, if you are having an electric field in this direction, which is perpendicular, and when electric field and magnetic fields both are perpendicular to each other. Okay. Now in this case, in this direction, if you are having motion of the charged particle, and motion of the charged particle in this direction, electric field and magnetic field both are perpendicular to each other. The same thing what we have discussed earlier, when it will be going for a circular motion, when all the three will be perpendicular to each other, when velocity will be perpendicular to both electric and magnetic field. Okay, so in that case, what will be there? The total force F is equal to QE plus QVB. Correct?
Yes, sir.
Yes or no? So Q E vector plus V vector into B vector. Right. So now this magnetic force, this velocity is selected in such a way. Velocity is selected in such a way that the force due to electric field and force due to magnetic field both are becoming equal. Both are becoming equal. Okay. Both are becoming equal in the sense that you can say it is becoming opposite. So F is equal to QE is in this side, suppose. So F is equal to QE due to that electric field in this direction, and magnetic field will be equal and opposite. It should be equal and opposite. So in this direction we are getting FB, which is QV into B. Okay. So what it says? It says that the velocity of charged particle is selected in such a way that the force on charge due to electric and magnetic field are forces on charge due to electric and magnetic field are equal and opposite. Are equal and opposite. Okay. So in this case, what will be there? In this case, you will be getting QE is equal to QV into B. As V into B are already perpendicular to each other, so we can write QVB. We can write or not?
Yes, sir.
So QE electric field is equal to QVB
Sin theta.
sin theta. So as it is perpendicular to each other, so sin 90 will be equal to 1. Okay, so due to that sin 90 is equal to 1, it will be just multiplication of their magnitudes. It will be just multiplication of their magnitudes. So this Q will get cancelled, and this V, what you are getting, it is electric field by magnetic field. So this ratio is adjusted. The ratio of electric field and magnetic field is adjusted in such a way that the maximum velocity can be obtained. So that's why it is called velocity selector. Okay, so this particular expression is called velocity selector, which is applied in cyclotron. Which will be applied in cyclotron. Okay, so this application of velocity selector is in cyclotron. Application of velocity selector is cyclotron, which is used to accelerate positively charged particles, not electron. Okay.
Yes, sir.
Protons, neutrons, okay. Alpha particles can be, you can say, accelerated, but not electron. Electron is not accelerated, right? Okay. Electron will get affected.
Yes, sir.
So, application of velocity selector is in cyclotron, which is used to accelerate positively charged particles. Okay? Right. So, this is the velocity selector.
Sir, if you cross multiply two vectors, you will get sin theta, sir. If you divide two vectors, you will get something, sir.
It will be dividing.
Two vectors,
Okay.
you will get some angle, something. Like sin theta, you will get something.
How you will get? You need to have angle only when you are having two vectors. Only when you are having two vectors. So you are knowing that when you are going for cross product of two vectors or dot product of two vectors,
Yes, sir.
then only angle between these two vectors will be there.
Yes, sir.
So if you are saying that one vector is at the numerator and another vector is at the denominator, okay, then how that angle will come here? Angle will be coming only in case of dot product or vector product. In dot product you are getting cos theta, in vector product you are getting sin theta. Okay,
Yes, sir.
so that is there. Just note it down. So this is the total force.
Yes, sir.
Okay. Total force. Now one more thing you see here, in one way more we can explain this. How we can explain? Now, see your electric field is in which direction? Y direction. You know that in x direction we are having normal, you can say unit vector what? I.
Yes, sir.
In y direction we are having unit vector j. And in z direction we are having unit vector k. So, by utilizing that vector product also, we can do it here. So, F is equal to QE plus QBP, right? So, QE, we can write that QE vector, so it is J unit vector because it is in y direction. Okay, so in y direction. So, this is F, E. Yes or no?
Yes, sir.
Right. Now, for this FB, this is FB only.
Yes, sir.
What we can write? Net force is equal to FE plus FB. Can we write
Yes, sir.
like this? Okay. FB is equal to Q B into B. Yes or no?
Yes, sir.
Right. Then Q. B is in which direction? In I direction.
VI.
So we can write B I unit vector into B in which direction?
K.
K. Okay. Unit vector. Right. Now it is giving us the product V into B and what I into K? You know in vector product, in dot product, in dot product which is called scalar product also.
Yes, sir.
You know that I dot I, J dot J is equal to K dot K is equal to 1.
1.
Okay? And I dot J, this is a vector. All are
Vectors.
vector. I dot J is equal to J dot K is equal to K dot I is equal to 0.
0.
Why?
Yes,
So what it is there? I dot I is equal to magnitude of I and then magnitude of I. Yes or no?
sir.
Cos theta. Angle between I and I.
It's 0.
0 only. So cos 0. Cos 0 is equal to 1. So I square. Magnitude I square. Okay. I dot j. What is the angle between both of them? I and j? 90 degree. X and y axis 90 degree. Similarly, all are 90 degree. So cos 90 is equal to 0. So it has become 0. Vector product now. Vector product. If you are going for I dot I, then what is the angle in vector product? I dot I. So is equal to what? I magnitude. I magnitude sin 0 degree.
Yes. So 0. Sir.
So it will become 0. So this part will become 0. Okay? And this I, J, J, K. So I, sorry here. Here vector product is there. Okay? So I dot J. Sorry, I into J, vector product is equal to K. It is following a cyclic path.
So
I, J, K,
again
I. Okay. So Ij will give you K. Okay. Jk will give you I. Ki
will give you
J.
Yes, sir.
Okay. So it is following a cyclic path. If any change is there, then it will become minus.
Minus.
Okay. So suppose Ij, I vector into J is equal to K. But if you are writing J into I, it will become minus. Understood now? Okay. So that part here it is coming into role. So what was there? K into I should become J. K into I should become J. Whereas here I into K is there. So it will become minus
J.
Minus J. Okay. So it is giving you minus Q V B minus J. Yes or no? Is equal to minus of QBB and J vector. J vector. Okay? So that's why this FB, see here.
Yes, sir.
That's why this FB, magnetic force, is negative direction of J. That minus is there, negative direction of Y direction.
Yes,
so that's why here it has come. So you can say, so now this velocity sector, so net force is becoming 0. In this case, net force is becoming 0. The velocity of particle is selected in such a way that the net force should be equal to 0. Okay, so what we can write here further, net force. So here we can write F is equal to QE J minus VB, sorry, VB. Can we write like this?
Yes, sir.
Huh? Okay. So now this has come here. So what will be their net force is 0. So its velocity of charged particle injected is selected in such a way that the forces on charge due to electric and magnetic field are equal and opposite. It means what? It means the net force on the particle will be 0. Okay, thereby here what we are getting here, if we are putting it equal to 0, 0 is equal to QE J minus B B right? J vector.
Q, sir.
Okay, Q. Right, Q. Now you can get it cancelled this one.
Yes,
when you are equating it both of them together. So you are getting the same thing.
Yes, sir.
Both are in same direction, JK direction it is there.
Other vector.
Okay, so QE, so you can say V is equal to E by B.
E J cap by B.
So this you can obtain it by using vector product.
Okay.
So that's why vector product is important to understand here. Right?
Yes.
So this is velocity selector. Okay?
Yes, sir.
Right. Next we will be studying about.
Sir.
So this is called crossed electric field. What it is called? Crossed. Okay, crossed fields. Crossed electric and magnetic field. Particularly, the name is given as crossed. Due to being equal and opposite crossed fields.
Yes.
Crossed fields. So the particle will get undeflected. There will not be any deflection. There will not be any force
Yes.
on this particle. When electric field and magnetic field both will be perpendicular to each other and it will be in opposite direction. The net force will be in opposite direction. So there will not be any force
Yes.
on the particle. Right. Good.